Hi, I'm Cheryl Leach. In this exercise, we're going to be talking about critical numbers. Well, what exactly is a critical number? A critical number is a value which makes the derivative equal to 0, or it could also make the derivative undefined. One more thing, we want to make sure when we're talking about critical numbers that the function is actually defined at those locations. That's what this first part of my definition requires. Okay, so I want to find out when a derivative is 0 and when it's undefined. Let's look at an example. f of x equals 4x squared minus 6x. I have two questions to ask myself. First of all, when is the derivative equal to 0? And secondly, when is the derivative undefined? Let's take it one step at a time. The derivative is 8x minus 6. When I set that equal to 0, I can solve for x and find that 6 is 8x and x is 6 over 8, which we could also write as 3/4. So now I know when the derivative is 0. Let's talk about when it's undefined. Well, here's my derivative, 8x minus 6. Is 8x minus 6 ever undefined? It's a line. It's defined for all points. So this never happens. So now let's check one more thing. Remember, I'm looking for points where the derivative is 0 and undefined, but the function has to be defined at that location. And at 3/4, am I allowed to plug 3/4 into my function? Absolutely, I can. So it is defined. My critical number is the point 3/4. Now, one more question would be, why do we need to do this anyway? Well, it turns out that later on when we start doing some applications, some very interesting things happen at the critical numbers. So it's a good idea to start practicing finding them right now. Thanks, I hope this helped.